Welcome back. In this Random Bits, we're going to create ourselves a virtual reality app for the Google Cardboard VR headset using Unity. So for those of you who don't know, the Google Cardboard headset is literally that. It's a piece of cardboard. It comes with some plastic lenses and a magnet that acts as a button, and you pop your phone in there, and it's a really cheap way of getting access to virtual reality experiences. It's about $15 US for a Google Cardboard device, and Google has a Google Virtual Reality SDK for Unity that allows you to create applications for the Google Cardboard headset using Unity. So the first thing we're going to do is fire up Unity, and we're going to create ourselves a new project, and we're going to call that project Google Cardboard Mars. We're going to create it as a 3D game, or a 3D project rather than a 2D project, 3D project, and we're going to create that. Right, once that's loaded, I am going to change my layout to the 4 split layout, and we've got our top, front, perspective and right views. Excellent. So the next thing we need to do is download the SDK. I'll put this link in the notes below the video, but if you go and browse the GitHub repository for this, there is this Unity package over here which you can click through and then click this raw button to download it, which I already have. Once you've downloaded that, we can go back to Unity, and then under Assets, Import Package, Custom Package, and then in my Downloads folder I can pick the Google VR for Unity.unity package, and we'll open that up. Alright, and just give it a moment to unpack the package. Cool. And so it's got all these prefabs and DLLs and other useful bits there. We want to import all of that, except we don't want to import the demo scene. So if we uncheck that, and we have the rest of this going on here, we are ready to roll. So we can then hit import. Right, and it will now import what we're looking for, all those assets. You'll notice it's imported some iOS pieces as well, so this application would work both on Android or iOS with the Google Cardboard headset. Alright, now because it's a VR application, what we actually require, or what the application generates, is a left and a right camera view. So you get left and right views for each eye, and the view is actually offset, so that gives you the stereoscopic or depth that you need to have a proper VR application. So to that end, what we're going to do is we're going to delete our main camera, and we can take out our directional light as well. And then we're going to do a search for an asset, for a prefab called GVR main, and we're going to drag that into our scene, and you'll see it's created a camera structure for us. And if you have a look inside here, it's got a head, which is the actually tracks all the head position of the and simulates where the user is pointing the Google Cardboard, under which we also have a left and right camera. Cool, so we'll put that into the scene. The other thing we will do is we will then, from the game object menu under 3D, we will add ourselves a sphere, and it's going to create it right in the middle of our view there. So what we want to do is just drag it a little in front of our camera over there, and move it a little further out. And we can also create ourselves a light. So from game object 3D under light rather, we're going to create ourselves a point light. Once again, that will put it in the center, so let's just grab that and drag that out to the side slightly over there somewhere. All right, and if we run the scene now, I'll just maximize on play and try that again. You'll see that it is rendering kind of the split view, so the left and the right views, and you can use the mouse pointer to click, and if you hold down the Alt key, it will simulate the user moving their head around and looking. So that's what they would see looking through the Google Cardboard device, the headset. And because you'll see it's probably a little hard to tell, but they're not perfectly aligned, and that's because we're simulating that left and right eye view so that you get a sense of depth when you look through the headset. All right. Let's just save the scene, and we're going to call the scene main, and we will also save the project. All right. So what we're actually going to do is we're going to create ourselves a space scene, and we're going to take the sphere and turn it into Mars, and then we're going to add a nice background showing the Milky Way so that we can view a scene in space. To do that, what we're going to need is a couple of texture maps, and there's this great site here, the Planet Pixel Emporium, which is a whole bunch of texture maps for all the various planets in our solar system. So I've picked on Mars, and from here we are going to download the color map and the normal map. So this will download, and we're going to grab those two and grab those two from my downloads folder and drag them into the project. Cool. And now we're going to create ourselves a new material. So we're going to go create, that was by right clicking in there, create material, and we're going to use the standard shader for the albedo, or the diffuse map, I suppose. We're going to click that little icon there and go and find our Mars color texture. Cool. And if you actually open up this little there, you can see what it's going to look like if you drag that around. And then we're also going to go for a normal map, and we're going to select the normal map. Cool. Now Unity will warn you, because we didn't change the import settings for the normal map, that it's not marked as a normal map, so we can just hit the fix now option on there, and that will fix that for us. And now we want to do a few more tweaks. So firstly, that's very shiny and very smooth, so instead we're going to set the smoothness to 0.2, make it slightly less shiny, and we're also going to the normal map is very subtle. So what we're going to do, just to make it a little bit more obvious, we're going to take the normal map power here and set that to 2, just so that this is a bit more detailed when we see it in the viewer. Cool. And then we're going to click on there and rename this to Mars texture. Awesome. Now we're going to take that Mars texture and drag it onto our sphere, and we're going to click on the sphere itself, and we're going to rename that to Mars. Cool. And if we run that now, we should have the planet Mars floating on a blue background. Cool. All right, so let's give this a little bit more life by making Mars spin slowly. So what we're going to do is we're going to save a project, go to our Mars, and we're going to add a component. We're going to go down to the bottom here, select new script, and we're going to call the script spin. Create an ad, and then we're going to open that script, and this will take a little while because it's going to fire up Visual Studio, but this is pretty much just going to be a script where we're going to specify a rotation rate, and pretty much every frame we're just going to rotate the sphere around the y-axis. So we just give this a moment to go. Right, so in our spin, what we are going to do is we're going to create ourselves a public float. We're going to call this degrees per second. And in our update method, we are going to say transform dot rotate around vector dot vector 3 dot up, and we're going to multiply that by the time dot delta time times the degrees per second. And I'll explain what this is doing in a moment. All right, so the degrees in second per second is a public float, so that means this will become, as you'll see when we flip back to Unity, a property we can change in the inspector. And in pretty much every frame, what we're going to do is we're going to rotate the object that the script is attached to, the transform. We're going to rotate that by the up vector, which is the y-axis, and we're going to multiply the up vector by the amount of time that has passed between frames. So time.delta time is a fractional value. A value of 1 is 1 second, so this will be like 0.0000 something of a second, and we're going to multiply that by the degrees per second. So pretty much if this was 1, we would move the full degrees per second, but because we're updating the frame multiple times per second, this will be a fraction of that degrees per second that we rotate every frame. All right, so that looks good. If we flip back to Unity, we give it a chance to compile, and it will add our new script over here, and we're going to set the degrees per second to 20 degrees. And if we run that now, right, we have our spinning Mars that we can hold down the Alt key and have a look around. All right. So the next thing we need to do is get rid of that blue background. And what we're going to do for that is we're going to create ourselves a skybox, which is basically, if you imagine putting yourself in a giant cube where every face is a part of a panoramic, and Unity has the ability to generate that from a panoramic image. So the panoramic image we're going to use is from the ESO, the European Southern Observatory, and they have a Milky Way panorama, which is a giant panorama. You can see that it can get quite large, of the Milky Way that they've stitched together. So what we're going to do is we're going to download the large JPEG. So we get this very large JPEG, which if we zoom in, we get lots and lots of details. You notice it's kind of squished there and there. The way these panoramic images work is there are a 2-to-1 ratio, so they're twice as wide as they are high. So it's an equirectangular panoramic image, and these are designed to basically be wrapped around a sphere to create a panoramic. So what we're going to do is we're going to just save image, drop that into our downloads folder, and then inside Unity we will drag that panoramic into Unity, and then we can click on it and select. So Unity will by default import this as a texture, but we actually want to turn it into a skybox. So what we're going to do is we're going to pick from the type, and we're going to say that it is a cube map, and we're going to leave the order map in order, but you'll see it can import different types of maps. We just leave it at auto, and we'll leave it by filtering thing, and we'll leave it at 2048. Although we can maybe bump up that resolution if we wanted a higher quality, but I'll leave it at 2048. And then we're going to hit apply. Now this is going to take a while, because what it's actually going to do is it's going to take this image and remap it so that it creates like 6 sides. If you imagine it's projected it out onto a cube. So if we hit apply here, this will take a while whilst it processes that image for us. Particularly if you set the resolution particularly high. Normally gets this far and then sits for a moment. Alright, so now the mapping is complete. And once again, if you see, it's just created this weird looking map here. So what we're going to do is we're going to back in here, is we're going to right click in there and create a new material. And we're going to change its type. We're going to go to skybox cube map. And from here, we're going to select the cube map we generated. All right. So you can now see in the preview window, you've got this panoramic view. You can pan around and have a look in. Okay. And we'll leave everything the same by default. We'll leave for the default. And we're just going to rename this one Milky Way. All right. Cool. Now what we need to do is add these to the camera, or the cameras, because we actually have 2 cameras. So if we pick on the main camera, we can actually just add it to the main camera and be done with it. It will then affect both of the child cameras. However, you can, in theory, if you had a panoramic image that was actually stereoscopic, so you had 2 panoramics taken slightly offset, you could actually attach it to the left and right cameras to achieve a stereoscopic view. But we'll just add it to the main camera. So the first thing on the main camera, if we pick the main camera, we're going to select the clear flag and we're going to set it to skybox. And then we're going to go and at the bottom here, add a component, and we're going to add a rendering component, and we're going to add a skybox. And then in its custom material, we can click on that and pick on Milky Way. Cool. Let's save that up. And if we run that now, you will see that we can now pan around a whole starscape. Awesome. Cool. So, probably what we want to do is add, like you always see in the space scenes, a much harder light source, because we have our light coming from over there, but it's kind of soft and wishy-washy at the moment. So if we go and grab our point light, we're going to rename this to Sun, and we can set its intensity. We can crank up its intensity slightly here. Maybe we will make it a 5, and we'll also pull it up a little. So if we have a look at that, we'll end up with a much harsher shadow. That's probably 2 in line. Let's bring it this way slightly and see if that looks better. I think I want to move it away a little, and maybe a bit further up. Nope, that's too far away. Cross it in. I think that will do. Not quite as harsh as I'd like. Let's move it a little closer. And maybe a little closer, more. Yeah, I think that'll work for me. So we can look around and we kind of got this harsher shadow line there. If you look carefully, you can see the bump maps because we've exaggerated them for the various super duper big mountains there. They're obviously not really that big in real life, but it adds a nice effect because you can kind of see the detail as it goes past there in the normal maps. Over there, for instance, and there, and there, and there. Cool. So the next thing we want to do is J.J. Abrams it a little bit, and let's add a lens flare, because what is a space scene without a giant lens flare? So this is pretty straightforward to do in Unity. So we're going to go to Assets, and we're going to import a package, and we're going to import the effects package. So this is the standard packages that come with Unity. So import package effects, and this will bring us a whole list of stuff. We can basically turn off everything and just scroll down to the easy way of selecting turning off everything is hit none, and then scroll down to the light flares and import the light flares. So we've imported that and click import. Cool. And then with our sun selected, if we go to the flare where it says flare none, if we click on that little button there, we'll get a flare, and I am going to choose a fairly dramatic one. We'll choose the 50mm zoom, which you see looks something like that, so fairly dramatic. So if we run that, we see this there, and then as we look across, we'll get a nice giant lens flare in our space scene, just for kicks. All right, let's save project there. Okay. So the last thing to do is to handle input. So the Google Cardboard is fairly simplistic. If we look back at the screen, at the actual cardboard, you'll see it's got a single button on it. If you look at the Get Cardboard here, you'll see that there's actually quite a different models. There's the one that Google, the original one that Google did. They've got a couple of generations where they have just slightly different buttons, and then there's also actually a bunch of companies who make plastic ones, which are probably slightly better quality than the cardboard ones. But they all have this button, and this button actually what it does is it moves a magnet, and they use the phone's accelerometer, or rather the compass, to detect the compass and accelerometers. The magnet affects those. So that's how it used to work in the original one. In the newer one, there's actually that cardboard thing there causes a screen touch to occur. So they've changed some things around, but pretty much you've got kind of two input methods. The first one is to press the button, and so you get a single click, and the other thing is by looking around. And so what Google has done is in a lot of their apps, if you tilt the headset 90 degrees, like on its side, then it considers that to be kind of like a back button. So you kind of have select and a back button. And the Google SDK provides a bunch of classes such as the gaze tracker and reticle and things like that, which allow you to target things on screen. So you can have a little cursor that you can point on and then press the button to select. So there's a whole bunch of things in the SDK for allowing you to do that. Cool. So if we go back to our code, what we want to do is on our GVR main, we're going to add a new component, and we're going to add a new script, and we're just going to call the script handle input, create an ad. We're going to open that up in our editor. And inside here in the update method, what we are going to do is say the following: if GVR viewer, if GVR viewer dot instance dot tilted. So in other words, the GVR viewer is a class that gives us access to a bunch of state about the headset and the head tracking, and it's a singleton, so we can do the class.instance will give us the instance, and what we do is we're going to look to see if the tilted flag is set to true. In other words, the headset's been rotated 90 degrees, or in this case we want to say the GVR viewer dot instance dot triggered, which is when we've pressed the button. If either of those happen, we're just going to do an application dot quit. All right. So that helps. Basically, it means if we tilt it or we press the button, we're just going to exit the app. Normally, you would do different things there, but I'm just going to do both of those in this case. I'm going to save that. It's saved, and then jump back to Unity. And we should be good to go. So if we run that, clicking and stuff, application.quit doesn't work inside the editor, but it will work when we build the application. All right, so we have our application. We're pretty much ready to roll. So the last thing we're going to do is build this for Android. So I'm going to click on my file, build settings. I'm going to select Android. I'm going to switch platform. It will redo all the imagery, and unfortunately it will probably rebuild the light box as well, so we just have to wait for that to finish. I mean the cube map for our Milky Way. So what it's doing now is it's reprocessing all the assets and recompressing them as needed, or adjusting them to run on Android. Or see, here we go again. Processing our Milky Way cube map. All right, finish the last few bits, and then what we need to do is hit player settings, and that will open up the player settings over here. We're going to call ourselves Rabbit Gremlin Limited. Call our thing Cardboard. Oops. Cardboard Mars. Don't have an icon to set for that just yet, but that's fine. And more importantly, we need to do a couple of things here. Firstly, to be able to build for Android, we need to give it a different bundle identifier, otherwise Unity won't let you build, so we're going to call that and Google Cardboard Mars. And then the other useful thing to do is under resolution and presentation. Google Cardboard only really works in landscape mode, so we can probably turn off both of the portrait modes, and we don't have an icon. Cool. Other settings, bundle, done. So we can file save project, and then we should be able to hit build and run. So I have my phone plugged in, so when I hit build.run, we'll just go and build a APK file, which is the packaging for a Google Android application. Google Cardboard Mars, and hit save, and it will now compile the application, map all the bundles, assets and stuff, build a APK file for it, and then upload it to my phone, which is plugged in via a USB cable. And then unfortunately you won't be able to see it, but yes, I'd be able to plug that into my Google Cardboard and have a look at Mars floating in the space. All right, well, that about wraps it up. If you liked this tutorial, please press the like button and tell others about it. And if you want to see more videos like this, please remember to subscribe.